Uh, Madison Board while playing a modified version of Link game and piles of stone where iron piles contains AI stones. We have two space separated integers n is the number of piles and d is the number of faces, which means the dice can have numbers 1 to d. The second line contains n space separated integers. So we have vector piles. So we need to find the probability of Alice winning the game. The condition is player must select exactly one non-empty pile and remove at least one stone from it. So these are the piles that we have, right? This will be have some number. This will be having some numbers. Uh, let's say 5, 6, 7, 9 random numbers. So Alice and Bobs will have their chances, right? So who will be picking up the stone is decided by who will win the toss. Or what is the toss? Both of them will be rolling the dice D, and whoever will get a bigger number will be winning the toss. So what is the total number of possibilities? A will have D, so Alice can have 1, 2, 3 till D, and the Bob can have 1, 2, 3 till D, right? Total number of possibilities and or the total number of combination of the numbers that both of these people will have will be d square. Okay, and in the question it is given that Alice will win. Uh, Alice will win if she have the greater number or both of them will get equal numbers, right? So let's see what is the probability of getting greater number, right? So the probability of getting a greater number is 1. If one player is getting 1, then the second player can get 2 to d minus 1. If the second player is getting 2, then 3 to d minus 1, right? So this will have d minus 1, this will have d minus 2 possibilities, so on. At last, we'll have one possibility, right? If one player is getting d minus 1, then the last player will get d. So this is one possibility. So total number of possibilities will be 1 plus 2 plus 3 till d minus 1. The sum of all of this will be d minus 1 into d by 2. And for Alice to win, she can also win if both of them will get equal numbers. So how many cases are there when both of them will get equal numbers? 1, 1, 2, 2 till d, right? So these are d cases. So d, right? So the chances of winning, Alice winning will be d plus this number d minus 1 d minus 1 into d by 2, right? Okay, so what is the sum? D minus 1 into d by 2. Sum is 2 into, okay, there is some sum. Let's say this is the, yeah, this is the other total number of in how many ways Alice can get win. Let's keep this with us. Where is the eraser? Yeah. Okay. So d plus d into d minus 1 by 2. And what was the uh, total number of possibilities? So they were d square, right? So now we have got the probability. So now from this we can calculate the probability of Alice winning the toss. What is the probability of Alice winning the toss? Probability of Alice winning the toss will be this numerator, right? Um, yeah, this numerator d plus d into d minus 1 by 2 upon d square, right? This will be the probability. Now, uh, the thing is, the one who will be winning the game will pick up the last stone. All right. So now let's move to the point on how to pick up stones. So we have Alice, Bob. These people will start picking up stone. Let's say Alice win the first one. It start picking up some stones from here, and Big Bob will pick from somewhere else, right? And there they will reach a point when there will be only one. So there will be only one pile that will be remaining, right? And let's say I'm Alice and my opponent is Bob, and I know that I should not be in a condition where there is no pile remaining, right? So in that case, if I am getting a chance to pick some number of stones from that last pile, I'll pick all of them. Otherwise, I know that Bob will pick all of them. Alright. So let's say we reached here somehow. So now this is the last pile. Okay. Now think about it. Does it really matter on like in what order all of the previous piles were completed? Does it really matter? No, because that is an independent event. So this is a concept of independent, right? Independent event. So if we like it doesn't really matter. What only matters is who will get who will win the toss when there will be only one pile remaining. So the probability of Alice winning the toss we have already calculated. Does it make sense? And the probability that Alice will win the toss we have already calculated, and I think that is what we need to know, right? So last one, yeah. So yeah, the probability. So P upon Q we have calculated, and we just need to output it in this manner. So what was P? So this is bullshit, right? This is bullshit. What is P? P is uh, D. What is P? D D into 2 plus D square minus D. Right? So D square plus D upon 2 D square. Right? Am I doing it right? D square plus D upon 2D square. So this will be D plus 1 upon 2D. Okay. Uh, So we have D, right? So D plus 1, and what will be Q? 2D. So what do we need to do now? So we have arrived at the solution. Now do the inverse modulo whatever. Read about how inverse modulo is done. I cannot recall as of now. Thank you. Bye.